Hi guys, so in the previous video we split the data based on date, and then we cleaned the learning data set. Then we used the information, the cutoff values from the learning data set to clean the testing data set. Now we're going to talk about other ways, and then at the very end we exported the testing. We didn't do that, so let's export the testing data set here. So this is the data set that we exported, test.to Excel, T data split. And this is the data that we exported. So now it is T data date split. Let's download this data and take a look at what we've done. So this is a data that is all totally clean. The only problem here is the basement. We agreed from last time that just for the sake of being very quick, I'm going to show you also how to use Excel for a little cleaning. If this is equal to minus A and F, then give me 0, else give me the value itself. And now we have 0 whenever that integer not found is found. So over here, I'm going to just copy this and paste it as you can see. I'll paste it as an integer, and then take the label as is, and then get rid of this. Save it. And save it over here. So I have L data, this is the T data, this is the testing data, and this testing data has the log transformation done nicely. Okay, I think I did it in such a way that I said it is I think the way I saved it is that it says L data and T data split, and then I think I added here an extension to it, which is saying base treated, to distinguish between the data that I am getting from the system, because the system, the data I got from the system, I didn't clean it yet with Python because of time limitation. I cleaned it with Excel right now because I didn't upload the code to you guys on Moodle. I uploaded the older code, but anyway, I'm gonna upload the newer code, so maybe in class we can just use Python. We see. All right, so there are other ways to splitting the data. So let's take the DF again, the original DF with the 21,000. Again, the one that we just read at the very beginning, and then we split it into whatever based on date. So before all this happened, this data frame was not split or anything, and this data frame, as you can see, we can split it based on different proportion. As we've shown in the previous class, you can split it based on date. If you have a year 2014, then year 2015, and it just happened that the learning data, which is the historical data or the older data for the years 2014, maybe 2015, whatever, they all up to 70, and the remaining is all up to 30. In this case, yes, why not? You can perform the date kind of you can actually perform it even if you have to split it halfway through in 2015. You can do that. It just happened in our case that in this data set that I provided you, is that it shows that 2014 is, as you can see here, is almost 70% of the data. Else you will have to use the date instead of just a year. Use the date as in day and month, and rank it based on the date, and find out the percentage for each row in Excel if you're happy with Excel, and then find out which date is the cutoff date that cuts off at the 70%. You can also do that with Python. Of course, the students who are taking fundamentals of Python this year, not the seniors, probably the freshmen will know how to do this easily with the professor teaching the course. As you can see, we are running out of time in this course, so I'm just going to run very quickly and do the 70-30% proportionate cuts. I don't like this for this data set. This data set, I think the best way to cut the data is through the date and not through this method. But if you have other data sets and you would like to split it into learning and testing, especially if it's the 1-0 kind of classification data sets for machine learning, then this is also a valid way that we use the sklearn library, as you can see here, the train test split method, so that we can split the data. So over here, first of all, we split the data into the independent variables and then the dependent variable, the price. After splitting the data into X and Y, we're gonna see that I'm putting here X2. Why did I put X2, by the way? And what's the... I hope I didn't delete the code now, because this will take me a little while now to write it with you. I maybe did. Yeah, I did. But in any case, you know something? I don't need to split it into X and Y. So yeah, I don't need to do that anymore in this class. So let's just do that this way. And let's say that we have because this I know why. Because this method, now I know why I split it that way. All right, so we have X and Y's, right? And we have Y over here. Then we have X train and so here is splitting the data into X train, X test, Y train, and Y test. This is how this method is designed, and this is probably why I splitted the data like this at the very beginning. But at my method, the date method, we don't need to split into X, Y train, and then now it's going to work just fine. So we have X train, X test, Y train, Y test. So this is how this method does things. This is an already built-in method that you need to split the data into X train, X test, and Y train, Y test. And then you can basically use this method, train, test, split, and then you can split it based on 30, maybe 70, or 30 to 70. Let's do the 30-70 rule that everybody does. And then now we can do the Y train. And then instead of Y2 and test 2, we are now putting these into, transforming these into, these are arrays. So splitting the data into training and testing data set, the output of the method train test split is arrays. So now we are going to transform the arrays into data frames. So using this function. Now we are gonna concatenate, yeah. Now we are going to concatenate the something happened here. Wait a minute. I have price here. so this is the df, and then we split it into x and y's, right? I know in advance that I don't need the square foot living and I don't need the square foot above, but it's okay. I'm gonna just leave it as is. This is the y. Now we split it, right? As you can see, it is all split into x train, x test, y train, y test. Print y train, here's y train, right? So now y train, we're gonna do it into a data frame, and this data y train, as you can see here, I'm gonna give it a column called price, and the y test also I'm gonna give it the column called price, right? And now I'm gonna do the y train and take a look, and it's all right. Okay. Now we can concatenate here the x and the y. Yes, so we need to concatenate. So let me do this right away here. So let's concatenate the x and the x train. And y a train into a train dataset, into dataset train. Okay, so, and likewise for learn, and likewise for learn. So what we need to do is, now we can use the concatenate from pandas because they are now data frames, and this method only takes data frames. This is why I transformed them into data frames. So now the x train and y train together are learn, and the y test and the x test together are test. And now we can print the shapes. Oh no, problems. Y train, y test. And what about x train, x test? We didn't actually. We need to do the same here. Okay, so we need to do here y x test. It's gonna be x test is really x test, and for x test these are all the x variables, right? So let's copy these variables, and these are the x variables. So we are going to transform these variables into, and the same applies for x learn, or x train it's called here, x train, and instead of x test it's a train. So this is y train, y test, x train, x test, and over here we are concatenating the y train with x train and concatenating the y test with x test, because this method from pandas, the concatenate, take only data frames into this. Likewise for learn, and this is why we do it this way. So now we have a test data. Here is test data 6,400, and here is a learn data which is 15,000. Okay, good. Now doing the investigation as usual. Here we've done this already. We've done the concatenation already. So all this we've done already. So right guys, so this is the other ways, and here we've done all these together. Now cleaning the data set, really. So now over here is cleaning the data set. Cleaning the learning data set. So as you guys see here, so the way that you clean the data set is exactly the same as we've done earlier. So here's your data set. You're going to take a look at what you've got here. I don't like learn and train here because it is the same as learn and train previously, right? Test and learn. So let's at least put this in a format that it is learning and testing. How about that? This way, learning, you see, and it's 15. You see, it was returning. Yeah, you see, I need different naming. I like different naming because then we know that this is the second method. So instead of learn, we're gonna just use learning, and here we go. This is the learning, and this is over here. We're gonna transform it into a log transformation. So we can write this code. As you can see, while I am fixing my code, you could probably write the code or copy it and execute it on your computer as I'm giving this tutorial. And now let's take a look at the box plot and investigate the presence of outliers. Of course, now the only difference is we are going to use we are still in the learning. We're gonna compute again all the quartiles based on this new split method, of course. So over here we have 11.6 and 14.4. Is it the same? Just being curious. This is 11.6, 14.4. I think 14.4 was the same. (11.6, 14.4), almost the same. So it is the same readings, as you can see, but let's make sure that I'm using the right data sets. I'm using learning here. Yeah, not learning. Okay. What if we split it differently? And this is one of the things that I'm going to show you, I'm going to ask you to do in the test. For example, split it instead of 30 and 70. As you can see here, it's very close to what we have done with the date. Yeah, I'm going to ask you to split it into 2080, for example. So this is one of the things we could also do, to split it into 2080, for example. That would be interesting to find. All right, so now that in fact, why not do it right now? But well, we'll do it in class. And split it like this in class. And then you just need to do the learning here. You need to clean the data. So please make sure that you clean your data by removing all the outliers beyond the upper and lower whiskers. And then once you've done that, you are ready to make sure that there's no outliers in the learning data set. Now that you have a same situation with the log transformation, but instead of learn to here, I'm going to just put learning, and same applies here. So basically we are doing the log transformation for all the log for all the variables. All right. I think there's some problems here. Based on the multicollinearity test, we don't need the log for above. We don't need the log for living, but rather we need the log for basement instead. And I don't see basement there. Lot, living 15, lot 15. This is perfect. So instead of above, I'm going to put basement, because based on the multicollinearity test, we don't need the square foot living, and we need lot and lot 15 and living 15. So now this is okay. Basement maybe has some problems. No, here learning has the problem. So here learning, we just need to put learning in here. Okay, now we have no problems. It's just telling us that basement has problems. So we need to drop all the variables here. Above, basement, square foot, all that. Yes, and then after that we're gonna print the variables. So let me just take this and put it one step at a time. So here's the drop, And after dropping the variables, maybe it is very nice for it would be nice if we can take a look at the learning data right now after we drop the variables. Okay, because we already dropped the variables, right? The variables are already dropped. This is why it's giving me the error. So let's take a look at the learning data. So learning data now doesn't have any of the variables that we don't want in there. And now let's plot the transformed variables. So here's the, no. So you can just plot the transformed variables as we've done earlier over here, yeah? If you want to take a look at them. So let's just very quickly do it together before time passes by very quickly. Do it over here. So we just need to put learning instead, and then that's it. We generate the figures, and it's supposed to be all right, except for the fact that we in fact used, instead of log variables here, used something called variables, and instead of the log variables we used variables equal to learning, and then we logged in all the variables we want except basement, right? Because basement causes us problems, giving us trouble because it has the integer not found. So let's get rid of that. And now we probably, what happened now? Just need to get going with this. Let's see what we were doing before. Sorry, here. Should work fine. Yeah, it worked fine now. I don't know what was the problem. And little things maybe. Variables. So now this is all done. So let's take the learning, and instead of L data prop split cleaned, so this is what we need to export. So now this is our data. Let's take a look at our data. So L prop proportionate, proportion wise split. Let's take a look at the proportion wise split. This is the learning data. Let's take a look at the learning data, 14,900 after the cleaning. We still have this problem, so I'm gonna just fix it very quickly right now with you. So over here we just put if this variable, this cell is integer not found, give me 0, else give me the value itself. And now you can just copy that and paste it again and put it as integer. Copy that over here and get rid of this. And now I'm going to save this file, save as I'll save it as, here I'm going to save it as L data proportion is cleaned, and here basement treated. Okay. So this to distinguish the output from the system versus the output after cleaning the basement with Excel. Alright, so now let's do the cleaning the testing data set. So we have a learning and the testing data set. Same applies, exact same thing. We are going to plot the price on the testing, and then we are going to clean the price on the testing, as you can see here. So we are going to do the cleaning. And same applies here. And now we just want to visualize the data, the testing data. And of course we expect having some outliers. So this is the testing data price after cleaning. Seems like it is not as problematic here as with the date. So this is why, if you don't want to do it by date, it's okay, because actually because it's randomized, it has less chances of giving us outliers after cleaning. All right, so now that we've done here the testing lower than the upper whisker, lower whisker, I'm just not sure which lower and upper whisker now is been giving. So this is why I'd really like to change, even in class, I would like to change the whiskers here, names, into here, the whiskers, after we split everything. I would like to change these whiskers name into lower whisker 1, lower whisker 2, and all these actually. Or put the whole thing in a new in a new file, and this is what I'm going to do, in fact, so that it's easier for us to follow up with things and the naming also. So this is a good practice, in fact, so that we know for sure that this upper whisker is based on our cleaning. So this is straightforward, guys. This is all now straightforward. We don't need the log transformation for above. We don't need the log transformation for living. We need it for basement. Same situation, lot 15, living 15. This is supposed to be basement. This is lot 15, living 15 from the previous class. And now we should be, instead of test 2 we have testing, right? And test 2 we don't, this is my file previously, now it is testing. So here we go, and this is, instead of test 2 we just need testing. And instead of living, and we have to put it as basement, so I'm going to take basement from here. So basement lot, no above, square lot, living lot 15, living 15, okay. And then now we just need to drop square foot basement, lot, above also, all the others really. So I'm gonna also add here square foot underscore above, I don't need it, and also square foot underscore living, I don't need it, right? So I'm gonna drop these all together. Okay, and then now we are going to visualize, but in the visualization, as you can see, lot 15, living 15, living. I don't need living and living 15 due to the, and above, due to the fact that with multicollinearity we got rid of them. And over here, basement will give me trouble plotting all of them together. So I'm going to do this code again. I'm going to run this code again, and this is the results. Now we can just take testing and put here testing data proportionate and create this file, Excel file, and get it from here. Let's take a look at our testing file, test split proportionate here. Download, let's see. Aha, there's problems. Where is the basement? No, there's no problems. But above, as you can see, it wasn't deleted. The square foot living is not deleted. We don't need square foot living or square foot above. So I'm gonna refuse to just compromise on this. I need to take a look what happened when we dropped the variables. I think when we dropped the variables, what happened is some variables were already dropped over here. So just temporarily for now, I'm gonna get rid of living and basement and lot, right? Above and living, right? They were not deleted yet. So let me run this code now. It will have no problems. Do you see that? And now it has no problems. And now let's create the Excel sheet. Now creating the Excel, do you see why the problem happens? The problems happens because we already dropped the variables, and again we're dropping the variables that already don't exist. They already dropped. So this causing us a bit of trouble. So over here, let's download this Excel sheet and see if it's all right. As you can see here, all is good. We have square foot basement only has a problem. So we're gonna fix it as usual, which is if this is equal to not integer, give me 0, else give me 1. Sorry, not give me 1, else give me the reading itself, the value of this cell. So over here it's going to be the same, and copy this and paste it on top of it with integer form with the and here clear delete. Good. And then let's save this. Save it here as clean, and then base treated. Do you see that? Here we go. So now this is how we do it. I'm gonna of course use this file with you in class, so we're gonna work with this file in class together and work on splitting and cleaning the data again. Cleaning the data again after splitting. What does this mean? This means that you are going to be trained again on cleaning the data. So if cleaning data was a bit difficult for you last time, now also we're going to do it together. So this will be like the, you know how many times we're cleaning data? Training, testing, training, testing, 4 more times. So we've done it once or twice before, and now we're 4 more times we're cleaning the data. So I think this is enough training for you for cleaning data. And of course, the splitting is just easy. I showed you the code on how to split on basis of date and on basis of proportion, like 30, 70%, and so on. All right, lovely people, this is it for today. I'll see you then in class, and take care of yourself and stay safe.